Okay, so last section we're going to look at this week is section 10.1. We started out doing conics. Okay, we did the parabola. No, we did ellipse. We did hyperbola. We're done with that. Okay, on the test, probably have about 6 or 7 questions on that stuff. Okay? The remaining 5 or 6 questions is going to be on the stuff we do today. Okay, so the test is only about maybe 12 or 13 questions. But you can still get partial credit, especially when you're solving a system. If you get one letter right and one letter wrong, you get half credit, stuff like that. Okay, so what does it mean to have a system of equations? Versus, like, if you see the direction, solve the equation, versus solve the system of equations. What's the difference?
It'd be like a bunch of equations, and you have to figure out certain variables.
Yeah. So when we're solving a system of equations, that means you're solving for at least 2 variables. Now, the way we're going to do it is the number of variables you're solving for is going to match the number of equations I give you. That doesn't always have to happen. You can be solving for more variables than you have equations. You can be solving for less variables than you have equations. And then weird things can happen. But we're pretty much going to stick with, if you're solving 3 variables, I'm going to give you 3 equations. Or if it's a word problem, there is 1 word problem on the test, you'll have to come up with the equations yourself. Okay. So for this one, I just want to set up the system. We're going to solve it in the next example, but for now I just want to set it up, and then we're going to talk about substitution. And then we'll come back and solve it. Now, this one says find the length and width of a rectangle, and they give you some conditions. The perimeter is 100, the area is 300. Now, if you're trying to set up a system of equations from a word problem, it's your job to figure out the equations. But you don't really have to start from scratch here, right? There's 2 formulas you should use, and they involve a rectangle. What's one of the formulas that I need to use involving a rectangle and the information from the board? Yep.
Length times width equals area.
Okay, so you don't have to invent a formula, you should know one. Area equals length times width. And what's the other formula we're going to use? It's going to involve not area, but perimeter. What's the formula for the perimeter of a rectangle?
2 length plus 2 width.
Yep. 2 times the length, because you get 2 of those. 2 times the width, you get 2 of those. And you add them all up. So now we're just going to fill in what we know. Okay. What does it say that the area is? 300. So fill that in. 300 equals L times W. Okay. What else can I fill in?
For that equation?
That equation's pretty much done for now.
That's what kind of the perimeter.
Yep. What's the perimeter?
100.
100 equals 2L plus 2W. Without that second equation, if all I said to you is, okay, I'm thinking of a rectangle and the area is 300, how many answers would there be? Infinite. I mean, I could be thinking of a rectangle that's 30 by 10. Could be 3 by 100. Could be 60 by, yeah, 60, what would that be? 60 by 5 is 300. So there's lots of different numbers that multiply to give you 300. But if you're telling me they have to multiply to give me 300 and the perimeter has to be 100, that's going to narrow down my answers. Okay, so that's all we wanted to do for that one. Just set up the system. So the 2 methods that we're going to look at for solving systems in this section are substitution and elimination. Only one of these methods would really be good for this problem. Anybody know which one would be the right method here? Yeah?
It would be substitution.
It would be substitution. So I'm just going to briefly explain what substitution is. If you already know it, then you don't feel you have to write anything down, then don't worry about it. But we're just going to quickly go over what it is. So the way you do substitution is you pick one of your equations and you get a variable by itself. So pick an equation, make that decision, and then look at the equation, pick a letter that you want to get by itself. Once you do that, you're going to take what you got by itself in the first step, and you're going to plug it in for that variable in the other equation. So you're going to rearrange the first equation, and whatever you rearrange, you're going to use that and plug it into the second equation. Now, if you've done step 2 correctly, you should have only one variable in your equation now. So you're going to solve. You're going to simplify what you have and solve it. And at the end of step 2, you're going to know one of your answers. But don't forget, when you're solving a system, there's more than one answer to find. So after step 2, you know your first answer, then you're going to plug that answer back in and get the other answer. Now, I will plug the answer from step 2 into one of the original equations. It doesn't matter which one. If you've done everything correct, you can pick either equation and you'll get the same answer. If you notice that you take your answer from step 2 and you plug it into one equation and you get an answer, and then you plug it into another equation and you get a different answer, then you did something wrong. Bless you. Okay, so any questions on the general idea of substitution? And at this point, that's Algebra 1 stuff, so we really should probably be pretty good with that. Okay, so let's take the problem we just had. I'll make it L's and W's again. So 2L plus 2W equals 100. L times W equals 300. Does it really matter what letters you use? No, it doesn't really. All right, so step 1, pick an equation, and then within that equation, choose a letter you want to get by itself. So which equation do you think is easier to work with here to get a letter by itself?
Bottom one.
Yeah, I think the bottom one. You can do one step and get a letter by itself in the bottom. You can't do that in the top. If you want to get L or W by itself in the top, you have to do 2 steps. So Sam, what letter do you want to get by itself in the bottom?
Let's go with L.
L, okay? So now I want to know, using the bottom equation, what does L equal?
300 over W.
Yep, 300 divided by W. Now, all we have to do is find W, and then I have a formula right here that'll give me L. Once I know W, L is 300 divided by whatever W is. Okay. Now, Carolyn, what am I going to do with the 300 divided by W? Well, what's the second step in substitution? Okay, so where would you plug that back in? Yep, and in which equation would you plug it into? Well, that's the equation we already worked with. Yeah, we got to do it with the other equation. Okay, so let's fill in right there. Instead of L, I want to write 300 divided by W. Now, I'm going to double it as we go. So what do you get if you double 300 divided by W? 600 divided by W. Okay. So now you've doubled L plus 2W equals 100. Now, what I don't like here is this fraction. Usually when we're solving an equation, if it doesn't have fractions, that's easier. So how could I get rid of this divide by W? And I'd have to do it here, here, and here, all 3 spots. Yeah?
Multiply by W?
Yeah, you can multiply everything by W, that's fine. But you got to do it here, here, and here. So here it cancels. What's 2w times w? Oh, Nick? Nope, that's 2w plus w.
2w squared.
2w squared, yep. And Isaac, 100 times w? 100w. Look at what we've got there. What kind of equation is that? It's not in the order we normally write this kind of equation, but it's a what?
Quadratic.
Yeah, it's a quadratic equation. So when we solve a quadratic equation, whether you're going to factor it or use quadratic formula, what do you usually try to get a quadratic equal to?
0.
Yeah, we try to get it equal to 0. So let's move this over to the other side. And I'm going to write it in the normal order. 2w squared minus 100w plus 600 equals 0. Now from here, it's just solving a quadratic. That's it. So I get to choose. I can try to factor it or I can use quadratic formula. But regardless of which method I want to use, I could make these numbers a little easier to work with. Did anybody see what you could do? By doing what?
Dividing by 2.
Yeah, you can divide everything by 2. I mean, it doesn't make the numbers that much smaller, but makes them half as big. So w squared minus 50w plus 300 equals 0. Now, to factor it, you'd be looking for two numbers that multiply to give you 300 and add or subtract to give you negative 50. Well, it's not going to work. Right? You can try it. You can, if you're stuck because 300 is kind of big, you could start listing out everything. You've got 1 and 300, 2 and 150, 3 and 100. I mean, you can keep going. 5 and 60, but you're never going to find two numbers that add to give you 50. So it's not factorable. So what's the other method you can use if you can't factor a quadratic? Yep.
Graphing and find zeros.
You could. Yep, we did a lot of that in the beginning of the year. You could graph it, find the zeros. What's another method? Quadratic formula. Yep. So for that, I need A, B, and C. What's A here?
1.
Yep. It's not written, but it's a 1. B and C. Okay, so when I write the quadratic formula, what's the first thing I write?
No, is it b squared plus or minus?
B squared is in there somewhere. Yes. Yep. Negative b. Yep. So 50. Then what? Then the plus or minus.
Square root.
Square root.
4ac.
A little more than that. Yep.
Isn't it 4ac, right?
B squared.
B squared minus 4ac. So b squared is just negative 50 times negative 50. That's just 2,500. Minus 4ac. Let's see if we can do that as we go. What's 4 times a?
That's a challenging one.
Yeah, it's going to get harder.
4.
Yep. Times 300. I got a big number. 4 times 300.
1,200.
1,200. High level stuff. So b squared minus 4ac, and then it's all divided by 2a.
Oh, okay.
2, in this case, a is 1, so it's just 2 times 1. Okay, let's see what we get. Okay, keep in mind what letter I'm solving for. W. That's what I'm trying to find right now. I'm getting the width. 50 plus or minus the square root of, what's 2,500 minus 1,200? About that.
There's
1,300 divided by 2. Okay. So there's 2 answers. Now, you could tell that one of them is really wrong if it came out to what kind of number? negative, right? With negative width, that wouldn't make sense. If you get a negative, you can cross it out. If you don't, then you write both answers. 50 plus the square root of 1300 gives me 86, whatever. Divide by 2, 43.03. I'm going to call that width 1. And over here, I'm going to write down width 2. So it's 50 minus the square root of 1300. And then divide by 2. Does it come out negative? No, it doesn't. 6.97. Okay, so I got 2 answers. Solving a system. Am I good? No, not good yet. What am I missing?
Okay, the answer is 2.
And that's going to give me the length. Well, the formula for length is right here. 300 divided by the width. So let's take 300, scroll back down. 300 divided by, I'm going to do 43.03. Look what I just got. 6.97. So what do you think L2 is going to be?
43.03.
It's going to be, if I did 300 divided by 43.03, or 6.97, it would be 43.03. So we just found the length and the width of rectangles. So what's the difference between the 2 rectangles?
The sides. One, the width is longer, while the other one, the length is longer.
Yeah, I guess it's basically, you know, are you looking at the rectangle this way, or are you looking at the rectangle this way? The answers are congruent, but there are 2 because you could have the rectangle turn 2 different ways. So technically, there are 2 answers. Okay. Any questions on that? Okay, so once we set up the system, just had to use substitution, and then it turned into a quadratic. Not every problem is going to be quadratic, just the way this one worked out. Okay, let's look at this one. Now, we're going to use substitution again, but this one is also set up to use the second method we're going to talk about next, which is elimination. Okay? But substitution wouldn't be that bad to use here. Which equation, top or bottom, would it be easier to get something by itself? Top. And which letter would be the easiest?
Why?
Yeah. If you look for a letter that has a coefficient of 1, that's always the easiest thing to get by itself. I'm just going to put an arrow. And Haley, if I get y by itself in the top equation, what would it equal?
2x minus 5.
So we've got
Negative 2x. Wouldn't you just subtract the 2x?
So what would you get?
Negative 2x plus 5.
Negative 2x plus 5. Yep. So you could say it one of 2 ways. I think the first time you said 2x minus 5.
Yeah.
What you could say is you could say 5 minus 2x, that's fine. Or you could say negative 2x plus 5. If you're thinking y equals mx plus b, that's probably why people would write it this way. But since we're using substitution, 5 minus 2x works. Okay. Right. And Connor, what am I going to do with that negative 2x plus 5?
You're going to plug it in for y in the second equation.
Yep. I'm going to plug it in for y right there. So I'm going to do 3x plus. Now, can someone tell me how to write it when I plug it in? Because I have to be careful how I write this.
2 parentheses.
Yes, 2 parentheses. That's what I was looking for. It's a distributive property. What's being multiplied by 2? The y. Well, the y has negative 2x and a plus 5 when you substitute. So 2 things are being doubled. And what's that equal to? 2. Okay, so distribute 3x. That's actually going to become minus 4x plus 10 equals 2. How about, Jaden, when I combine like terms on the left, what do I get?
Negative x.
Negative x. I'm also going to bring the 10 to the other side in the same step. Now in Algebra 1, I probably wouldn't do that, but I mean, we should be able to handle multiple steps. And now, Alec, what do I get for x?
It would just be x equals 8.
Yep. Now, what am I going to do with the x equals 8, Sam?
I just plug it into that equation up there.
Yep. We're going to take that, plug it back in right there. So when I do that, Sam, what would I get? What's negative 2 times 8?
Negative 60
Plus
plus
5.
5, that'd be negative 11.
Yep. And there's your y value. Any questions on that? Okay, so substitution works fine. It's not a bad method, but there's other methods that are a little bit better, especially when you get into ones with 3 variables, and that's elimination. So everything we do for the rest of today is going to be based on elimination. So elimination is when you have equations and you try to get the numbers in front of the variables to be opposite. Try to get the numbers in front of the variable to be opposite. Which variable? Any variable you want. Pick a variable. Because if you can get the numbers to be opposites, then they cancel out. You can do it if they're the same, but we're going to think of it as making them opposites. So get the coefficients of one variable to be opposites. Now, what that might mean is you might have to multiply an equation by a number. Okay? But we kind of did that when we solved the quadratic. We didn't multiply, but we divided everything by 2. That's kind of like what we're going to do here. We're going to multiply everything by a constant. But you have to do it everywhere, every spot. And you might have to do it to just one, or you might have to do it to both equations. So let's look at an example. All right, we're going to start out with one with 2 variables. When we get to 3 variables, it's a lot more steps, but it's the same thing. You just have to do it a lot of times. Okay, so here's our system. Now, the reason I would kind of shy away from substitution is because I can't easily get x or y by itself. And if I did, I'm going to end up with lots of fractions. Maybe the final answer is going to have fractions anyway. If the answer is going to have fractions, it's going to have fractions. Doesn't matter how you solve it. But maybe we can avoid fractions for now. So let's pick the x's or the y's. Do we want to try to make the x's opposites, or do we want to make the y's opposites?
Y's.
The y's, okay? So that means you want those 2 numbers to be opposites. So the way we figure it out is we got to figure out what our target number is.
Wait, but aren't 2 and negative 3 are you?
I would have done the x's, yeah, but we're going to do the y's.
Why?
Why not? I see what I did there.
It's not really that much harder.
Shut up.
But yes, the x's were already opposites, so that would have been part of it. Well, one's positive, one's negative, so at least the signs were opposite. Here, they're both positive, but that's okay. So we got to figure out what the target number is. Okay, the target number is the least common multiple of 3 and 5. Okay. So what's the least common multiple of 3 and 5?
15.
15. So our goal is to make one of these numbers a 15 and make one of these numbers a negative 15. Right? What could I multiply the top equation by to make that happen? And you've got 2 choices here. Negative 5, okay? So we're going to multiply that by negative 5. That's going to give me negative 10x then minus 15y, and then negative 5 times 5, negative 25. Okay, now I said you had choices in the top equation. You don't have any more choices. What would you have to multiply the bottom by? You've got to multiply it by 3. 3, 3, 3. Okay, when I multiply by 3, Nick, what's negative 3x times 3?
Negative 9x.
Negative 9x. Connor, what's 5y times 3?
Y.
15y. Good. And Carolyn, what's 21 times 3? Sorry, what was it? 63. Now, look what happened. You're going to add the columns up. Negative 15, positive 15, gone. So that cancels out. Sam, what's negative 10x plus negative 9x?
Negative 19x.
Yep. And lastly, negative 25 plus 63.
Negative.
Well, think of it as 63 minus 25.
38.
38, yep. Now, these answers don't always have nice numbers, but I will tell you that the more complicated ones on the test, especially the 3-variable ones, there will not be any decimal answers. All right, so now, what would be my last step to get x by itself? Divide by negative 19, divide by negative 19, x equals how much?
Negative 2.
Yep. Now, just like we did before, plug it back in, and now we can get y. Which equation, I mean, you can pick either one, but do you think the top or the bottom would be easier?
Probably the top.
Yeah, maybe the top, because at least the top, it had all positive numbers, and they're smaller. So, plug that back in, and we're going to get negative 4 plus 3y equals 5. 3y equals 9. Y equals 3. Yep. Okay, so pretty straightforward 2-variable system using elimination. Any questions on that? All right. So, if you think of these are lines, right? They have an x and a y, and if I wanted, I could rearrange these into y equals mx plus b, okay? In fact, we had one equation, I think it was Haley earlier, she did rearrange it into y equals mx plus b. Slope was negative 2, y-intercept was 5. Now, when you draw 2 lines, there's 3 different things that can happen. What could happen when you draw 2 lines? I'm thinking about like intersections. Think of one thing that could happen when you draw 2 lines?
They could intersect
Okay, yeah, they could intersect. How many times?
once.
Sure. So they could intersect 1 time. Line, line. There you go. That's the kind of problem we just did right here. If you were to graph these on the calculator, get y by itself, they would cross 1 time. Where would they cross? We just found that out. Negative 2, comma 3. That's the point where they cross. What else could happen if you draw 2 lines? Yeah?
Is it just like 2 solutions and then no solutions?
The only way you could get 2 solutions if you had like a curve and a line. Then you could get 2. But a line and a line can never cross exactly twice.
So you can get no solution.
How could you get no solution?
If they never cross each other.
They never cross
They're
each other.
parallel.
If they're parallel. So if you draw 2 lines, like y equals 3x plus 4, y equals 3x plus 7. Well, they're the same slope, different y-intercept, they're never going to cross. No solution. What's the third thing that could happen?
Perpendicular?
That would be an example of a 1 solution, where they just cross 1 time. Yeah?
Infinite solutions?
How would that happen?
If the two lines are identical.
Yep, infinite. So here's a line, here's another line. Exactly on top of each other. They cross everywhere. So infinite solutions. Now you might say, well, isn't it obvious if you have infinite solutions? Well, let's say you had something like that and something like this. Let's say I don't know. Is that obvious that those are the same line? They are. If
I
you
mean, I guess you can sort of guess because like they're all divisible by 2.
yeah, all I did was I doubled everything in the top equation and then I just moved something over to the
Yeah.
other side.
So you can like guess, but like you won't automatically know.
That's the same as 2y equals 4x plus 12 and then divide everything by 2. Y equals 2x plus 6. Y equals 2x plus 6. So you might be given two things that look different, but they really are the same thing. Okay. So let's look at an example of what happens when we do elimination and one of those things happens. We already know what happens when we get one solution. That's what we did in example 3. So this is either going to be no solution or infinite. All right. So first thing I check for when I do elimination, are my x's lined up? Yep. Are my y's lined up? Yeah, they are. Are my numbers lined up? Yes. Everything's lined up. Let's pick a variable. We did y last time. Let's do x. What could we multiply the top equation by to make the x's opposites?
3.
Just 3. Yeah, we don't want to do -3 because they already have opposite signs. So just 3. 3, 3, 3. Okay. Devin, if I do that, what's my top equation turn into?
It's going to be 6x negative 3y equals 15.
6x, can you say it again?
6x negative 9y equals 15.
Negative 9y equals 15. And now let's add up the columns. What's 6x minus 6x? 0. Gone. What's negative 9y plus 9y? Gone. I have 0 on the left. All my letters disappeared. What's on the right?
5.
Well, we're adding, right?
Oh, 25.
25. All right, we're done the problem. Now we have to write the answer.
What's the answer?
What's the answer?
No solution.
No solution. You ended up with a statement that's not true. If you end up with something like that, that means no solution. What do you think it would look like if the answer was all real numbers? What do you think this last step right here would look like? It could be 25 equals 25, or 20 equals 20, or 5 equals... Whatever it is, you'd have the same number on the left and the right. Okay. All right. 0 equals 0. Sometimes that comes up a lot. But if you end up with the same number equal to the same number, the answer is infinite solutions. It's infinite. What are the solutions? All numbers. All real numbers. Okay. So, any questions on that? That's a special case. Okay. This is the other special case if we went through and did it, where you would get 0 equals 0. Okay, I wasn't going to go through and solve this one, but if you multiply everything by 2 in the top, 2, negative 2, negative 6, 6, negative 4, 4. Everything cancels out, and you end up with this. So the answer is all real numbers. How many answers is that? Infinite. So any questions on the 2-variable 2 equation? Okay. So the last problem we're going to look at is 3-variable. Now, every time you add a variable, when you're solving a system, it doesn't just take a little longer, it takes a lot longer. So like when you go from 2 to 3, you think, yeah, that's one number, 2 to 3, big deal. There's a lot more steps. And if you go from 3 to 4, or if you go from like 4 to 5, it's like a crazy amount of steps. Like the number of steps quickly gets into like hundreds of steps. We're not going to be in hundreds of steps with 3 variables, but we're probably going to be like, I don't know, if you look at a problem like this and you say, well, maybe this had like 4 or so steps. You have to distribute a number, add some things up.
Most of them are in your head though.
So that's pretty easy. Yeah. Still, most of these steps are going to be in your head, but you're probably going to have between 10 and 20 steps.
Oh.
So, the way you're going to do it, kind of like we did before, you're going to pick a variable to be eliminated in 2 of the equations. And you're going to have to do that twice. So you're going to pick a variable to be eliminated in 2 of the equations. You're going to have 3 equations to pick from. Okay, you're going to have to do that twice. Then, using the 2 equations that you created from step 1, you're going to do it again. You're going to eliminate another variable. Okay? So the idea is, after you do step 1, you're going to take your problem and turn it into a 2-variable problem. So you start with 3, we're going to turn it into 2. That's a little simpler. Then we're going to do it again. We're going to eliminate another variable. Well, if you have a 2-variable problem and you eliminate 1 more, now you're down to 1. Once you're down to 1 variable, you can solve for it. And then once you get the first variable, you can use substitution and go back and get another one, and use substitution again and go back and get another one. Okay, so when we set this up, you're going to have options. You're going to have lots of options to pick from. You're going to have 3 equations to pick from. Each equation is going to have 3 letters. But I've already told you, I'm not going to give you a problem that comes out to fractions. So if you get fractions as you're working through the problem, that's okay. If your final answer comes out to a fraction on the test, no. You're not going to get fraction or decimal answers with this kind of problem. Okay, so let's look at our problem. So the first equation is 2x plus 3y minus z equals -1. The second equation, 3x minus 2y plus 2z equals 15. And the third equation, x plus 4y minus 3z equals -8. Now, sometimes if it's a 2-variable 2 equation, you can guess the answer. Like if it's not that bad, you can kind of figure it out. You're not guessing the answer there. No way. You're not going to be able to just play with random numbers for x and y in any reasonable amount of time and just guess. Especially if the answers could come out to fractions. Now, I already told you they won't, but that's not always true. Okay. And in the homework, there might be one that's a fraction. Okay, so first step is we're going to pick 2 equations. When I write a number and I circle it, that stands for an equation. Equation 1, equation 2, equation 3. Just a shorter way for me to talk about them. So out of those 3 equations, does anybody see a letter that they want to try to eliminate?
X is already by itself.
So what letter? Yeah? If you pick the wrong letter, I will correct you, because I don't want to do this a certain way. You could do Z, it wouldn't be that bad. But when I look for a letter I want to eliminate, I look for a letter that has a 1 in front of it, because that's easy to work with. So what letter do you think I'm thinking of?
The equation 3 of x.
X. So not just in equation 3, we're going to have to get rid of it everywhere. But X is the letter that I want to focus on. Now, which 2 equations do we want to work with first? 3 and 1. 3 is always the one you want to use, but we're going to work with 3 and 1. So 1 and 3. This is going to be a lot of copying, but I'm going to copy it down so I don't have to keep scrolling up and down. So equation 1 is 2x plus 3y minus z equals, was it 1? Negative 1. If I make a mistake, let me know, because it's very easy to make a mistake. And then x plus 4y minus 3z equals negative 8. So my goal here is to get rid of the x's. You can do whatever you need to make that happen. Personally, I think you only need to multiply the bottom equation by a certain number. What could you multiply the bottom equation by? And it would cancel out your x's. Negative 2. So top equation, I'm going to copy it over again. If you don't want to keep copying it, you don't have to. 2x plus 3y minus z equals negative 1. Now multiply everything in the bottom by negative 2. What's negative 2 times x?
Negative 2x.
Yep, negative 2x. What's negative 2 times 4y?
Negative 8y.
Negative 8y. And what's negative 2 times negative 3z?
6.
6z. And what's negative 2 times negative 8?
16.
16. Okay. Now we're going to add those up. What happens to my x's when I add?
They can't.
Gone. What happens to my y's?
That's negative 5.
Negative 5y. My z's?
Becomes 5z.
5z. And my constant?
It becomes 15.
Becomes 15. Now, something special happened here, and this doesn't always happen, but I can actually simplify that equation a little bit. I can make all the numbers a little smaller by doing what? Yeah, I can divide everything by 5. You don't have to do that, but if you do, it's going to make it easier later on. So let's divide everything by 5. Negative y plus z equals 3. I'm going to put a box around that, and I'm going to call that equation 4. I'm done with it for now. But notice what I've got. 2 variables. I got rid of one of them. Okay. Now I have to do that one more time. But you can't pick a different variable. You've got to get rid of x again. But you don't want to use equations 1 and 3. You already did it. Pick 2 other equations to do it. So what other equations could I use besides 1 and 3? 2 and
4. You said we had to use different.
we got to go back to the original ones.
Can't
Yep.
use the same pair. So 2
Oh,
and
the
3.
same.
I would use 2 and 3. Yep. Pick another pair of original equations. So now we're going to do 2 and 3, and we're going to do the same thing we just did. I'm going to copy down 2 and 3. So 3x minus 2y plus 2z equals 15. And equation 3, x plus 4y minus 3z equals negative 8. Okay, so you have to get rid of the same variable. So what variable are we getting rid of?
X.
Yep. And which equation are you going to modify to make that happen?
Or at the bottom.
The bottom, whatever one, the bottom one is here. And what would you multiply it by to make that happen?
Negative 30.
Yep, perfect. Top equation, I'm just going to copy it over. A lot of copying. 3x minus 2y plus 2z equals 15. Okay. And Haley in the bottom equation, what's negative 3 times x?
Negative 3x.
Yeah. And Devin, negative 3 times 4y.
Negative 12.
And what else? Anything else with it?
Why?
Y. Yep. And Sam, negative 3 times 3z.
Negative 9z.
Negative times negative.
Oh, sorry, positive 9.
Positive. And Connor, negative 3 times negative 8. 24. Okay. Add them up. What happens when you add up your x's?
Cancel.
Gone. When you add up your y's?
Negative 14y.
Negative 14y. Your z's?
11z.
And then z. And your constants?
39.
39. So now, let's call that equation 5. What we've done now is we've turned the problem that had 3 variables into a problem like this. 2 equations, 2 letters. Okay, let's go back. two equations, 4 and 5. They each have two letters. So now we're going to do it one more time. We're going to get rid of either y or z in equations 4 and 5. Okay, so let me just copy them down. Negative y plus z equals 3. And negative 14y plus 11z equals 39. So now you've got a choice. You can pick y or z. So which letter do you guys want to eliminate?
Let's go with Z.
Z? Okay. Which equation would we have to change to make that happen?
The top one.
The top one. What would you have to multiply it by?
Negative 11.
Yep, negative 11. Okay, so I'm going to copy I usually copy the one that doesn't change first. Negative 14y plus 11z equals 39. Now, what's negative y times negative 11?
11y.
11y. Negative 11 times z.
Negative 11z.
And negative 11 times 3.
Negative 33.
Negative 33. So now, even though we don't even have an answer yet, we've already done like 80% of the work in this problem. Once you get the first answer, all the other ones come very, very fast. So we're like 75% of the way done, even though we don't even have an answer yet. All right. What's 11 plus negative 14?
Negative 3y.
Negative 3y. The z's are gone. And what's negative 33 plus 39?
6.
6. So, what does y equal?
Negative 2.
Negative 2. Now, how do we get z? I would just go back to equation 4. That's probably the easiest way to get z. Bless you. You could use equation 5, but I don't like equation 5 because the numbers are bigger. So let's copy down equation 4. What is it? Negative y plus z equals 3. And what are we going to fill in for y?
Negative 2.
Negative 2. So if you fill that in, what's negative? Negative 2.
2.
2 plus z equals 3. So what's z? 1. There's our second answer. Now we've got y, we've got z. What are we missing?
X.
X. For that, you can't go back to equation 5. There's no x in it. You can't go back to equation 4. We already used it. You've got to go back to one of the originals. Which equation do you want to use to find x? 1, 2, or 3?
3.
3, okay. That's probably a good idea because there's a 1 already in front of the x. Can somebody just tell me what equation 3 is? So I know.
X. That's all I got.
That's all I remember.
Plus 4 minus
Plus 4y
3z
minus 3z
equals negative 8.
equals negative 8. Okay, so x, y is negative 2. What's 4 times negative 2?
Negative 8.
Negative 8. Now, negative 3 times z is 1. What's negative 3 times 1?
Negative 3.
Negative 3 equals negative 8. What's negative 8 minus 3?
Negative 11.
Negative 11. So that would mean x would equal
3.
3. Yep. So x is 3, y is 2, negative 2, and z is 1. Some people write their answer like this. 3, comma, negative 2, comma, 1. That's fine too. Okay, so that's how you solve a 3x3 system. So just kind of summarize it. Pick two equations, get rid of the same letter twice. Take those two equations, get rid of another letter. Now you have your first answer. Plug that back in, you get your second answer. Plug both of those in, you get your third answer. All right. But there's a lot of freedom in how you do it. I usually, again, if you find something with a 1, that's probably the letter to focus on. Now, this one I'm not going to go through, but what do you notice here?
There's no y.
There's no y, so what is it?
0.
It's a 0. So try to take advantage of that,
Set
right?
it equal.
Might be
Equal.
that might be helpful,
Well, we already done.
might be less work, right? Because you already have something that's a 0, so look at that. You already got an equation where y is missing. Maybe you just want to try to get rid of y in one more spot. And then you already have 2 equations with y gone, right? If you don't want to deal with y and take advantage of that 0, okay. Get rid of the x's just like we did before. But I think in this case, getting rid of the x's is more work. I would go for the y's. So any question on that? All right, so on the test tomorrow, okay, the kind of word problem you're going to have is going to involve 2 variables and 2 equations. Okay? It's going to be something like having to do with like a ticket sale problem. So I might say something like, you know, Monty Tech is selling tickets. Student tickets are $10. Adult tickets, like if you're not a student, are $20. Okay? So I'll tell you how much each ticket is. And then I might say, okay, for the musical, they sold 1,000 tickets and they made $5,000. How many of each type of ticket did they sell? So you have to set up a system of equations. One equation has to do with how many tickets they sold. The other equation has to do with how much money they made. So I'll tell you both of those things. Any questions on that idea? It's going to be a very classic, that's a very typical kind of problem, you know, ticket sales. And I think there might be one like that in the homework tonight with 2 variables. But that's the only, I think that's the only word problem on the test. All right, so matrices, we're never really going to get into how to solve systems with matrices. That would have been tomorrow. But the nice thing about a matrix is if I want to write all this stuff down right here, all I have to write is this. So what it basically does is it shortens up me having to write an equal sign and having to write letters. You don't write matrix letters when you use matrices. So is it less writing? A little bit. Still a lot of writing, but it's nowhere near as much writing as we just did in this problem. I mean, imagine writing all that without having to write any equal signs, any x's, any y's, or any z's. It's probably like 30 things I wouldn't have to write. Probably be a lot. Okay, but we're not going to get into matrices. Okay, so the homework tonight, back in your book, you don't need the packet. It's 541, 1 through 19 odd. Okay, as a reminder, I will be after school a little bit today. Probably about 40 minutes. So we get out at 2:40, so that'd be like 3:20. So probably till like 3:15, yeah, 3:15, 3:20, right around now. Okay, and then I'll be after school tomorrow, my normal time.